So we'll start the Moore sequence detector design part. So last class we seen about this what we discussed that Moore machine for different 101 sequence overlapping and non-overlapping. No, I will tell you the non-overlapping. You can design the overlapping sequence. Is it fine? I'll tell you. I'll tell you which one means Mealy overlapping sequence. I will tell you. Non-overlapping you do. Mm, okay, your response? Yeah. Uh, so the sequence detector steps are same, means whatever I steps, whatever the sequence detector for Moore machine. So whatever the steps I gave in the Mealy machine, that steps are same only. Okay. First what is the first step? Sequence detector, sequence detector, Moore machine, Moore machine. Okay. So sequence detector Moore machine. First, first what you need to do, draw the state diagram. Okay. Step one, first you need to draw the state diagram. Okay. Non-overlapping case we already seen, no? So this is nothing but what S naught by 0. Okay. So if it is, I'm checking for which sequence 101 sequence. Okay. So 101 sequence means what? If it is 0, it will be in the same state. Okay. And if it is 1, it will go to the next state. To go to the next state. This is S1 by 0. Okay, if it is 1, it will go to the next state. And next, if it is that S1, I need to check for 0 and 1. If it is 0, so after 1, I'm expecting, here I got 1, I'm expecting what 0. So it will go to the next state. It will go to the next state, S2 by 0. Okay, S2 by 0. And if it is 1, okay, if it is 1, it will be in the same state. If it is 1, it will be in the same state. And at H2, so here I got the sequence 1, 0. Okay. And at H2, I need to check for 0 and 1. This I am doing for which one? Overlapping says. Overlapping. Okay. Overlapping I am doing. At H2, I need to check for 0 and 1. If it is 0, where it will go? If it is 0, where it will go? It will go to S naught. Okay. If it is 0, it will go to S naught. And next it is 2 by, here I got the sequence 1. Okay. If it is 1, I'm expecting 1. Okay. After 1, I'm expecting 1. It will go to S2. Okay. S3. This is S3. S3 and output is 1. Okay. So I seen two cases for at S2 and at S1, at S3, I need to check for both 1 and 0. So 1, 0, 1. After that, if I am getting 0, okay. So if I am getting 0, this is overlapping. So 1, 0 is overlapping means where it will go? It will go to S2. Okay. If it is 0, 0, it will go to S2. And if it is 1, okay, 1, 0, 1, next 1. So if I am seeing two cases, that is not satisfying. So it will go to, means 1 is satisfying. So it will go to S1. It will go to S1. So this we discussed in the last class, no? Is it fine? Your response? Okay. This is step 1. And step 2, what you need to do? Step 2, write the state table with present state and next state. Okay. So write the state table with present state and state I need to draw. Okay. So present state and next state, next state. So this is for what? X equal to 0 and x equal to 1. Okay. And next output. Okay. Output Z. Output Z. Okay. So present state. So present state is S naught. So here x equal to 0. So what is the next state? It will be in the same state, no? S naught. And x equal to 1, it will go to the next state, S1. And what is the output? Output is 0 only. Okay. And you are not getting any sequence, output will be 0 only. Okay. And next at S1, at S1, so when x equal to 0, it will go to the next state, S2. By seeing the state diagram, I'm drawing the state table. Is it fine? Give response. Okay. Next S1. So when x equal to 1, it will be S1, and I am not getting whole sequence. That output is 0 only. And at S2, tell me. So when it is 0, it will go to S naught, and x equal to 1, it will go to where? S3,
Yes.
and output is 0. Okay. And at S3, uh, it will go to where? When x equal to 0, it will go to S2. Okay, overlapping, and it is go to x equal to S1, and you here at S3 you are getting output is 1.
Output one.
Okay, so this is nothing but what? State table. Okay, state table with present state and next state. State table with present state and next state. Okay, present state and next state. And what is the next step? Step 3. Step 3. Assign the unique codes. No,
VLSI.
assign the unique codes. Okay, so what are the unique codes I need to assign? S0 equal to what? 0 0, and S1 equal to 0 1, and S2 equal to 1 0, S3 equal to 1 1. Okay, now you draw this. So here itself I am drawing present state, next state, and output z. Okay, so this is x equal to 0 and x equal to 1. I think if I draw in the next slide, I think it will be easy for me. Okay. um, okay, next slide I will draw. Okay, this one. Okay, no, this step 2, state table with present state and next state. Hello, is it fine now?
Yes, sir. Yes, sir.
Okay. Okay, okay. So next, you need to draw the, so you need to give the unique codes in step 3, and you need to draw the state assignment table. State assignment table. State assignment table. Okay. So, so some disturbance is coming. Just to mute yourself. Present state. Okay. And next state, and x equal to 0, and x equal to 1. Okay. And next output z. Okay, so output z. So here, uh, present state 0 0 0 1 1 0 1 1. Okay, these are the states. You need to give the unique codes. Okay, so here, x equal to 0, it will go to s naught. It is nothing but 0 0, and x equal to 1, it will go to s1, that is 0 1, and at s1, x equal to 0, it will go to s2, 1 0, and x equal to 1, it will go to s1, that is 0 1,
Zero.
and s2, x equal to 0, it will go to what? S naught, and x equal to 1, it will go to where? S3. Okay, and at s3, x equal to 0, it will go to which one? S2, 1 0, and x equal to 1, it will go to s1. S1 means 0 1. Okay, and what is the output? 0 0 0 1.
Zero one.
Okay, so this is nothing but state assignment table. Okay, state table, state assignment table. So next you need to draw the detailed state assignment table. Detailed state assignment table. Detailed state assignment table. So how to draw the detailed state assignment table? Present state. Okay, so let us take the present state as nothing but q1, q naught. Okay, and
Output.
mm, input. Okay,
Output.
input. 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 So this is x. Okay, and next state,
Next state.
Next state, let us take Q1 plus and Q naught plus. Okay, Q naught plus. Next, flip-flop inputs. Flip-flop inputs. Here I'm using D1 and D naught. Okay, D flip-flop. Okay. So why I'm using D flip-flop? Why I'm using D flip-flop? Tell me, anyone? Why I'm using D flip-flop for the designing? Hello. Anyone give response? Shivani?
Sir, because it can act as buffer.
No. For the D flip-flop, if you see the excitation table, next state means D input equal to what? D input equal to that is you are getting Qn plus 1, no? D input equal to Qn plus 1 you are getting. So that means if you know this Q1 plus and Q naught plus, directly you can write the D inputs. Okay. So that is the main advantage of D flip-flop. Okay. D flip-flop also you can draw. There you need to draw the XOR operation. Okay. So three inputs are there. How many possible combinations? How many possible? Eight possible combinations. 0, 1, 0, 0, 1, 1, and next 1, 0, 1, 0, 1, and next 1, 1, 0, 1, 1, 1. Tell me. By 6, what is the next state? When 0, present state is 0, 0, x equal to 0, what next state? 0. Okay. But I'm in this table and I'm drawing here. When present state is 0, 0, input is 1, what is the next state? 0, 1.
0, 1.
Okay. Next, this is completed. Next, this one you see. Present state is 0, 1, x equal to 0. What is the next state? 1, 0.
1, 0.
Okay. And present state is 0, 1, x equal to 1. What is the next state?
1, 0.
0, 1.
0.
0, 1. Present state is 1, 0, and x equal to 0. What is the next state? 0, 0. Okay. And present state is 1, 0, x equal to 1. What is the next state? 1, 1. Okay. Present state is 1, 1, and x equal to 0. What is the next state? 1, 0. Okay. This one I am. And the present state is 1, 1, and x equal to 1. What is the next state? 0, 1. Okay. Now 0, 1. And next, tell me. So that means whatever is Q1 plus 1, that you can write as D1. That is 0, 0, 1, 0, 0, 1, and 1, 0. Okay. And D naught, whatever the Q naught plus are there, that you can write 0, 1, 0, 1, 0, 1, and 0, 1. Okay. And Z outputs, here anyway 0 you'll get. Okay. Here you will get 0. But at last, 2 ones you'll get. Why? Because
You'll get 1.
for 1, 1,
1.
present state is x equal to 0 and x equal to 1. You are getting output equal to what? 1. Okay. Is it fine? X detailed state assignment table.
Yes. Yes, sir.
Next, D1 equal to what I can write? Summation of M of, tell me, tell me,
2,
2, next,
5, 5, 6.
5, 5, 6. Okay, 2, 5, 6. D not equal to summation of M of, tell me,
1, 1,
mm,
3, 5, 7.
mm, 3, 5, 7, 5, 7. Z equal to summation of M
6,
of
7.
6, 7. Draw the K map and get the expression. Draw the K map and get the expression. Inputs are Q1, Q naught, and X. I want the expression. K-map.
D not equal to X.
D not equal to X. Okay. D not X. Yeah. D not equal to X. D1
Z
equal to
equal to Q1 Q naught.
Z equal to Q1 Q naught.
Q.
Okay. Q1 Q naught. Hmm. Z equal to Q1 Q naught. Okay. Next. D1 equal to what?
D1 equal to Q naught X bar
Q naught X bar
plus
Q naught X bar plus plus Q1 Q naught bar X. Okay, okay, okay. This is the expression. Okay. Now I am drawing. Okay, all are correct. Okay. Mm. Next, I am drawing the diagram. Moore machine overlapping for 101 sequence. So this is nothing but D naught, Q naught, D1, Q1, D1, Q1. Okay. So here D naught equal to what X? D naught equal to X directly it is sitting. And common clock for two flops. This is synchronous sequential circuit. Common clock for two flip flops. Clock is common. And yeah. So D1 equal to what? One is X bar. Okay. X bar and Q naught. Okay. Q naught. It is giving through one AND gate and one more AND gate. One more AND gate. One more AND gate. For this AND gate, so X is one input. X is one input. Q naught bar. Q naught bar means you can take from here. This is Q naught bar, no? So Q naught bar. So you can take from here. Okay. Q naught bar and Q1. Q1. So Q1 you can take from here. And this is connected with an OR gate. Is connected with an OR gate. And this is given to this one. So this is D flip flop. Is it fine how I designed? Okay. Any doubt in this? Anyone?
No.
Okay. Okay. Shall we move to serial adder next? We completed with this Moore machine. Okay. Sequence detector. Next is serial adder. Okay. Serial adder, Mealy today we'll see and Moore tomorrow we'll see. Okay. Anyone, any queries, any doubts you have in the FSM Moore machine? Shall I move forward?
Sir,
Hmm?
can you once draw 100 overlapping state diagram?
100,
Overlapping state diagram.
100 overlapping.
Yes, sir.
Okay, 100 overlapping. What is this? Moore or Moore machine?
More, sir.
More emission. Okay, more emission I will draw. Okay. So that means here you have how many states? So total you have four states. Okay, four states. First S naught, S naught, S naught by zero. Okay, it's not. I'm expecting what either zero or one. Okay, if it is zero, it will be in the same state. If it is zero, it will be in the same state. If it is one, okay, so that means one sequence I got, so it will go to the next sequence. Okay, so this is nothing but what S1 by one, S1 by one, and here I got one sequence one. Okay, here I got one, and next you see at S1 I need to check for zero and one. Two cases I need to check. Okay, so if it is zero, simply it will go to the next step. So I got one sequence from this. Okay. So this is the S2 by see this is zero. I didn't got the sequence, no. This is zero. Okay. Didn't got the sequence. So here I got one zero. This is nothing but zero. Okay. And if it is zero, where it will go? Tell me
next state.
where it will go. If it is zero, okay, next state. If it is one, same state, no?
Same state.
Same state. Okay. At S2, I need to check for 0 and 1. If it is 0, I got the sequence. Okay, it will go to the next state. S3 by 1. Okay, S3 by 1. So I got the sequence 1, 0, 0 sequence. Okay. So this is nothing but 0. This is nothing but 0. At S2, if it is 1, okay, if it is 1, it will go to the initial state. Where is the initial state? Tell me.
S1.
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 S1. Okay, it will go to the initial state. Okay, so here for S2 I checked for 0 and 1. At S3 I need to check for 0 and 1. Okay, so if it is a 0, where it will go overlapping or non-overlapping, you are asking?
Overlapping, sir.
Overlapping. Okay, overlapping means here 1 0 0 I got. Next 0 if I see, so I am checking for two bits not matching. So two bits, this is 0 0, this is 1 0, not matching. 0 1 is matching, no? So 0 is matching. So 0 is matching means where it will go, tell me. 0 is matching.
S0.
It's not. It's not. So this is S not. 0 is matching. Okay. And 1 0 0. After that, if I get 1, I'm checking for 2 bits. 2 bits not matching. Uh, Final bit, last bit, 1 bit I will match. Where it will go? Tell me.
S1.
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 S1. S1 means this is 1. Okay. So this is overlapping Moore emission.
So for 100, for both overlapping, non-overlapping, we'll get the same state diagram.
Same, huh? Okay, same diagram. Same. Actually, suppose if it is 1 0 1 0 0 1 0 0. After that, if I am getting 0 means it will go to this one. And 1 0 0. After that, if I am getting 1 means it will start from the initial state, no? Non-overlapping means it will start from where? It will start from
Overlapping, sir.
non-overlapping. So this is the only difference. For red I given no, why red this is for one. Overlapping means this one.
Previously, for everything, we did like that only, no?
Hmm. Okay. Okay. 101. How we did?
In 101,
Hmm.
sir, we have done this way only for non-overlapping.
Non-overlapping this way only. Non-overlapping. Mealy and Moore. That way only we
For
did.
Mealy, we did it like this only. Like
Ah.
initial means it will go to S0 whether it is 0 or 1.
Yes.
And
Yes.
in More, we did as like for S1, if it is 1, it will go to the initial one.
Mm-hmm. Okay. More non-overlap. Okay. 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 This I need to check. Whether only this one only, no?
That one and also
So for
110.
1,050, you have done
Which which one?
so for 101.
101. 101 I told you, no? More
101
model.
we got, sir.
101 you got, no? Mm. Mm.
So for non-overlapping, we have taken in this way only.
Mm-hmm. Okay. Mm. Overlapping. Okay. 1 second. We'll see. Otherwise, you take one random sequence and you try. So you'll get okay random sequence and you try so that you can draw the diagram. Yeah, sequence detector with overlap and non-overlap. 1011 you see 1011. This is Mealy machine. That I need to check and I will tell you. Okay, I'll check and tell you. Huh? Okay. Next what we'll do? Next what we'll do? We'll discuss some assignment questions. Tomorrow we'll start a serial adder. This question you see. mm, Suppose See this diagram. For the given sequence, the input sequence, what is the output for the input sequence? Can you say what is the output for input sequence? What is the output for input sequence? How to do? Any idea? Tell me.
Maybe first we should find out the sequence using state diagram.
Mm-hmm. Okay. Anyone? By seeing the state diagram, you can write the output sequence. No? By seeing the state diagram, you can write the output sequence. Okay. Simple only. Suppose if input is zero, what is the output sequence? Tell me. Input is zero. If input is zero, it will be in the same state. What is the output? Zero, no?
Zero.
This one is over. Okay. If input is zero, if input is zero, it will be in the state A only. Okay. If input is zero, what is the output? It will be the same state. Output is zero. If the input is one, it will go to which state? Next state. Next state means what is the output? Zero, no?
Zero.
Output is zero. Okay. So these are completed. Next. Uh, so you are at B. You are at B. Okay. So if input is what? Input is 0. What is the output? It will go to C state. And what is the output? What is the output? 1, no?
One.
If 1. Okay. So you are at which state? C state. Okay. You are at C state. Okay. And at C state, so this is completed and this is completed and this is completed. If input is 1, it will go to which state? Input is 1. It will go to again B state. Input is 1. It will go to B state. What is the so what is the output? 1. Okay. So output is 1. So 5 states are completed. Okay. And next, you are at B state. If input is 0, again it will come to C state. Output is what? 1. Okay. Output is 1. Okay. You are at C state. Again, input is 1 means any doubt? Hello. Yes. Input is 1. It will come to B state. It will come to B state. Output is 1. Okay. And if input is 1, you are at B state. It will come to D state. Okay. D state. That output is what? 0. Output is 0. Okay. And you are at D. Okay. Input is 0. It will come to which state? C state. It will come to C state. And the output is what? 0. Output is 0.
Zero.
Okay. And input is 1. Input is 1 means it will come to B state. Output is 1. Okay. And next. And input is 0. It will come to the C state. C state. So this is the output is 1. And input is 0. Where it will come? It will come to
A,
A state.
A.
A,
A
and
state.
output is 0. Okay. And input is 0. Input is 0 means it will be in the same state. It will be the same state and the output is 0. Okay. Again, input is 0. It will be in the same state. The output is 0. So this is the output sequence. Is it fine? Do you understand how I am drawing? Okay. From the state diagram, so how to do? That means depending on the sequence, you can draw the sequence. Okay. So this is one question. And next, you can expect like this question. Uh, so here, if you see for the state diagram, how many times The output, how many times will the output be one when the input sequence is? This one you try and tell me. How many times the output becomes one when the input sequence is given? One second, one second. Now is it visible? No. Okay. Now, now it's visible. Hmm.